Okay, this is section P2 and it's on integer, exponents, and polynomials. You'll need to know these rules for exponents. The first one is when you multiply, you need to add your exponents. For example, the 3 plus the 4 is the 7. When you divide, you subtract your exponents. 8 minus 4 is 4. When you have exponents raised to exponents, you multiply. 2 times 3 is 6. And this gives the reasons throughout the text. And also, anything to the 0 power is 1. So let's do a couple problems involving these. Here's a couple little ones. 4x cubed times 3x to the 4th. Well, 4 times 3 is 12, and that'd be x to the 7th. This divide, that'd be 2. Subtract your exponent, x to the 4th. Raising to a power, 2 to the 4th is 16. Multiply your exponent, so it'd be x to the 20th. 3 to the 5th is 243, and x squared raised to the 5th. Multiply your exponents, you get x to the 10th. And dividing here, 8 divided by 2 is 4, and when you're dividing, subtract your exponents, it'll be x to the 14th. We'll do a harder problem now. Before we do the harder problem, we need to realize what negative exponents do, and negative exponents really means to flip the base. So if we have 2 to the negative third, that's the same as 1 over 2 cubed, which is 1/8. 3x to the negative second, well, the only thing to the negative second power is the x, so just the x gets flipped down to the bottom. And 3x, the quantity raised to the negative second, would be 1 over 3x squared, which is 1 over 9x squared. I wanted to do one more little example before we do this big example here, and this maybe will show a little bit better why negative exponent means flip. This problem, x to the 5th over x to the 10th, when you divide, you subtract your exponent, so that'd be the same as x to the 5 minus 10, which is x to the negative 5th. Now, x to the negative 5th is fine, but we know that we should flip negative exponents and would be the same as 1 over x to the 5th. But we can also think of this problem as being that there's 10 x's multiplied together on the bottom, and there's 5 x's multiplied together on the top. So you have an extra 5 x's multiplied together on the bottom, and that's why there's x to the 5th on the bottom. In other words, we could also think of this problem as bringing this x to the 5th down to the bottom and making it 1 over x to the 10 minus 5, which would be 1 over x to the 5th. So that's why this answer is what it is. This answer follows the rule of exponents about dividing, you subtract your exponents. So therefore, this must equal this, and negative exponents does mean to flip the base. So now let's do this next problem. And when you do these problems, you need to make sure you do them in a very step-by-step process, dealing with the outermost parentheses and then working your way in. It's very easy to make a mistake, so make sure you be almost robotic-like.
We'll have to walk like robots, talk like robots, and if necessary, solve complex differential equations like robots.
Well, I don't know about differential equations, but we at least have to do this like robots, so here we go. Here's the problem. Now, the first thing I did is take care of the outermost negative exponents. So this exponent of negative 3 out here affects everything in the parentheses. So everything gets flipped. I'm taking care of the negative. So that whole 2x to the negative third, y to the negative 1 gets flipped down to the bottom and is now to the third power. Okay. This 6x is not affected by this negative 2, so it will stay on the bottom. But this x to the 5th, y to the negative third is raised to the negative second power, so it gets raised to the top and is now to the second power. Now I can distribute those powers through. X to the 5th raised to the second. When you have exponents raised to exponents, you multiply. So that would be x to the 10th. Negative 3 times 2 is negative 6. And I'm going to take this 3 through. Don't multiply before you do your exponents. So again, do it like a robot. Do it step by step. 2 cubed is 8. Negative 3 times 3 is negative 9. And negative 1 times 3 is negative 3. Okay, the next thing I did is I did multiply the 6x through now that I took care of the exponents. So 6 times 8 is 48. X to the first, that's an assumed 1 right there. X to the first, x to the negative 9th. 1 plus negative 9 is negative 8, and I have a y to the negative third. So that's all I did on that step. Now taking care of the remainder negative exponents, this negative 3 power on the y will flip it up to the top, and the y to the negative 6 will flip it down to the bottom. At this point, all we need to do is simplify this. X to the 10th times x to the 8th is x to the 18th. And we have a 48 that doesn't reduce with any other number up there, so it's just 48. And we have an extra 3 y's down on the bottom. So it would be a y to the third on the bottom. Okay, let's go ahead and do these next two examples. And you can always pause these problems if you want to, if you need to take a break.
Just get to work!
Okay, we'll just go ahead and do these next two examples. So simplifying this one, the negative exponent, that whole bit, gets flipped down on the bottom. This 2x to the negative 1, y to the negative second raised to the negative third, that negative third power is going to flip all that in the parentheses up to the top. So that's my first step. Taking this 3 through would give me 8, because the 2 cubed. Negative 1 times 3 is negative 3. Negative 2 times 3 is negative 6. Take the 4 through. 3 to the 4th, that's 81. X to the 4th. And then y to the negative 2 raised to the 4th. Multiply those and you get negative 8. Multiply your 6x through. 6 times 81 is 486. This is x to the 1st times x to the 4th, which is x to the 5th. So that's all I did that step. Now I take care of some remaining negative exponents. These two will get flipped down to the bottom, and this one will get flipped up to the top. The two x's here, adding your exponent will be x to the 8th. And you got 2 extra y's multiplied together on the top compared to down here. 8 minus 6 is 2, so that's why we have this. And the 8 over 486 did reduce down to 4 over 243, so that's that problem. This whole bit of stuff on this problem, example 4, is raised to the negative 4th, so that means the entire problem gets flipped. So the ab cubed is up on the top, and the a to the negative 5th and b is down the bottom. Now just take that 4th power through, and, well, I'll tell you what, we can simplify the inside first. Either way would be fine. A to the negative 5th, taking that up to the top, will give me a to the 6th, because it would be a to the 5th times another a, which is a to the 6th. We have 2 extra b's multiplied together on the top, so that would be b squared. Now we can take that 4th through, and it will be a lot easier. It will be a to the 24th, b to the 8th. So let's stop there on this problem. And I tell you what, you really work up a sweat doing these problems.
You know something, pal? You smell an awful lot like flowers.
Well, thank you, Mr. Hankey.